Welcome back. We're going to get more into ArcGIS Pro fun today, and this is going to be Lab 12, Basic Raster Analysis. This is some fun stuff. I really enjoyed this part because it kind of lets you see what's actually on the Earth, um, as classified by official sources. I've got the instruction open here, and it says we're going to use 2001, 2006, and 2011 National Land Cover Database data for Denton County in this lab. Um, we've got the objective. We're going to use the data to understand how land cover has changed in Denton County. Doing so will help you to understand the basic structure of categorical raster data. Hopefully you've already downloaded this data and extracted the files. The instruction tells you how to do this. I'm not going to go over that because it's you're just adding data. So what we're going to do here is I'm going to go on to number 2. It says open a new project, so that's what we're going to do. This is going to be for lab 12. Navigate to our folder. Tabs, hit OK. OK. And as always, we're going to turn off or remove the topographic layer when it comes up. There we go. Okay. So we've got that open. We're going to add the 3 raster files from our data that we downloaded. So we're going to go to Map, Add Data. We're going to navigate to our data. We have 12. National Land Cover Database. We've got 3 rasters here, right? So we'll just go ahead and add these 3. I'll shift click that, select all of them. We'll hit OK, and they'll pop up over here in the table of contents. It's going to look pretty funky. It's not going to look like anything you would see on like Google Earth or something like that. I'm going to go ahead and zoom in some here so we can see what we're looking at. Close this up a little bit. Just keep this one open. Matter of fact, I'm going to look at the oldest images. So we'll look at 2001. Okay. Your colors here are going to probably look different than mine. That's because ArcGIS Pro assigns these randomly. And what you're looking at here is you have a value right here, right? So you've got value 11 for this color. And this that's represented on this map in that color. I don't know which one that would be. I'm trying to cancel here. Yeah, but I mean, I just identified it, and we see that it says 22, right? So that corresponds with this. So whatever I selected in there was 22. You can zoom into here and look at it. If we want to see what this pink color is, it's probably going to be, what, 23? So let's click on it and see what happens. That's 22. Well, actually, that's for 2011. Click that. Click on this yellow one here. It should be 42, huh? Nope, 82. Huh. Oh, that's why. Yeah, how about that? Let's click on this purple here. Yeah, did in 2001. Here we go. So that's number 11. Oh, the value is for 82, so that's going to correspond with 82 here. I know what I'm doing here. It just takes me a second to get used to it. So yeah, you would have the value is 82, and that corresponds with this 82 over here, right? If we clicked on this bluish section here, that's 71. That's this right here, right? And each one of these pixels is a dimension. But we'll get to that in a little bit. So let's zoom out. We see that this color here, that's should be 11. Yeah, it's open water. 11, right? So that's kind of how that works. That's what the colors mean, and they're going to be different for each one, which is why I was having issues earlier. I didn't realize these were overlaid on top of each other until turned on. So if we opened it in 2006, it's going to look different. Not dramatically different, but yeah. And if we did that for DINT in 2011, it's going to look a little different there too. Right. Because like I said, ArcMap randomly assigns these colors. So there's that. So in the instruction on page 2 provides a legend. Okay, I'm going to go ahead and turn these layers back off. I'm going to bring this legend over just so we can see what we're talking about here. Hold on just a second. Let me get that legend. Here we go. Okay, so we've got our legend here, and remember when we were talking about those numbers for DINT in 2001, I clicked on this and it came up as 11, right? Well, if we look at what that corresponds with on the legend, number 11 corresponds with open water, right? So if we click on this purple here, don't worry about these colors because these colors are not going to match what's over here. If we click on this this purplish color here, that's going to correspond with 82. And if we look at our legend says 82 is cultivated crops. So all the purple on this map is represented by that purple, cultivated crops. This little pinkish color here, we'll click on that and see what that is. That's 22. And the legend says that that is 22 that's developed low intensity. Okay, then that's basically how all this works. We'll go ahead and close this. I'm going to bring the instruction back up on my map on my other monitor over here. So we're on page 3 with the legend, and it says on number 3 it says double click a raster layer in the table of contents to look at its properties. Since we have this one turned on, that's the one we're going to look at. We'll double click that and look at its properties here. In the properties window, we'll click source, and this is where you can see specific information about it, right? We see that this is a raster file. Its units are in meters. Okay, great. Let's see what else it says here. Primarily, you should be concerned with the information in the data source and in the raster information. Okay, so we also want to be concerned with information here in raster information, right? We see the number of rows and columns, that's fine. We see the number of bands. Cell size X, cell size Y are important. These are squares, right? So this is 30 by 30. So each of these cells here, each of these pixels is 30 by 30. What does that mean? Well, we say 30 by 30, but what unit is that in, right? We see that's in meters, so that's got to be 30 meters square. 30 by 30. 30 meters square, 900 square meters. And that's pretty much all you really need to know about some of this stuff. Go ahead and OK on this. We'll go on to number 4. So let's look at the attribute table for a raster layer. Right click this and we'll go into its attribute table. And you'll see that when I was talking earlier about those values are right here, right? So these values here all correspond with these values here. So we have, if we go ahead and select this right here, we'll see that it selects on our map right here, right? And all of these selected pixels, all of these selected cells correspond with 11. And on our legend, says that's open water. You don't have to pay attention to this color here. Don't worry about these colors here. Just worry about the number and the description. So value 11 is open water. Value 21 is developed open space. Value 22, develop low intensity, so on and so forth. Pretty easy stuff. We can look at number 42 here, right? Doesn't look like there's that much. Can't really see, where it's selected on here. That's because there's not many pixels selected. We'll get to that in a second. So number 4 says, look at the attribute table. We will concern ourselves with the value and count fields. I just went over the value field. The number here corresponds with the number in the legend. Right? This is open water. 21 is developed open space, so on and so forth. Pretty easy to realize. You just have to match the two together. The count. This is the number of pixels, the number of cells in this image that correspond with this value, right? So this is 228,918 pixels in this image are open water. If we would go down here to 42, we said that 42 was evergreen forest. Right? That's what our legend says. It says 42 is evergreen forest. 4,292 pixels in this image are classified as evergreen forest. Same for 52. 52 is dwarf scrub. And there are 1,002 pixels in this image classified as, actually that's 52 is shrub and scrub. So 1,002 pixels in this image are classified as shrub, scrub. Okay? Now, if we know the number of pixels in the image, then we can calculate its area, because we said that this is 30 meters by 30 meters, right? 900 square meters. Well, really, all you have to do is multiply that by the number of pixels, because each pixel is 900 square meters. So you just multiply this number here by the number of, by its area, and you'll get the number of square meters for your deal. So if you multiplied 1,002 by 900 square meters, you would come up with, let's find out. I'm doing the small numbers here because it's easier. 1,002 times 30 times 30. You could do 900. I just like doing it this way. This number here, 900, there are 901,800 square meters of this land type in this image. We'll do another one, 31. 31 corresponds with barren land, okay? And there are 4,070 pixels. Each pixel is 30 by 30, so we'll go 30 by 30. And then we said it was 31, yeah. So we'll multiply this by 4,070. We come up with 3,633,000 square meters of coverage here. Let me see what the quiz question is here. I'm not going to do like open water or anything. We'll do one more. 21. Yeah, that's a big number. Okay, so there are 174,278 pixels in this image. You can even see them. All the selected pixels are represented by 22. 22 is developed low intensity. And so to find the area of that, we'll multiply, these are 30 by 30 meter pixels with 30 by 30. And then we'll multiply that number by 161,942. And there are 145,747,800 square meters of coverage for developed low intensity in this image. All of these pixels that are selected, that represents 145,747,800 square meters. It's important to realize this. Simple math, but the concept can be a little bit challenging to understand. So I'm back in the instruction here. It basically says all of these things on page 4. Yeah, it gives examples of, different cell sizes. If the cell size is 10, then we 10 by 10, and then we multiply that count, multiply it by that count. So we'll go ahead and close this, and you don't have to do that for all of these, but well, actually, you're going to have to in your questions here. But no, I don't want that. I'm gonna go ahead and clear that. And so, yeah, I believe in your questions it's going to have something for open water, and you'll have to determine the change, because you can tell change. Let's go ahead and look at another one, matter of fact. We'll open the attribute table for this here, and we'll open the attribute table for this here. And so we know that open water is 11. The count is 227,000. So if we look at, and that's for Denton 2006. If the count changes, that means the area it's represented by it either increased or decreased, right? So let's look at another one. We'll look at number 5 is easy. Since it's a smaller, well, number 8 is the smallest number. We'll use that one. So that's represented as 52. So 52 in 2001, it was represented by 1,000 pixels, 1,002 pixels. In 2006, it was represented by 982 pixels. So it decreased just slightly. It went from 1,000 to 982. It decreased by 20-something pixels. So, a slight decrease. So that's how you can tell your land change, is to look at the difference between this year, this year's pixels with and this year's pixels. And it looks like, for like 95, that's 11,127. It went to 12,000. So it increased. 95, whatever that is for 95, that's emergent herbaceous wetlands. So that increased from this year to this year. And you can even look at that to like 22 is developed low intensity. So we'll look at that one. That's 172. Well, let's go into this one, the first one here. We're looking at 22. This 161,000. It went to 172,000. So it increased, right? There's more development. There's more low intensity development in this image. So it increased. So that's how you can tell the change differences, to compare those counts. Let's see what these say. Refer to the lecture notes carefully for instructions. I'm on page 4 in the note. Calculate the area for a given land cover class. You can do a new field. You don't have to, but if you wanted to calculate that, you could add a new field, I guess. I'm not going to do that. Okay, so question 1. What is the cell size of the rasters? We've talked about how to find that. You can find that in the properties. Question 2, what is a linear unit? We talked about that too. Should be pretty easy. What is the dominant land cover class? Denton County, 2001, 2006, 2011. That's pretty easy to figure out. What is the area in square kilometers? Square kilometers, not meters. Square kilometers. of deciduous forest in 2001. What is the question 5 is what is the area in square kilometers in 2006, and then question 6 is pretty much the same thing just for 2011. Easy stuff. Just remember to go. You need to convert your answer from meters into square kilometers. And it says here round to the whole nearest whole. Yeah, fine. And then question 7 says describe the changes in the total area of open water in Denton County from 2001 to 2006 to 2011. Well, we just went over that. So I showed you how to determine changes. So that's pretty easy. And there's no deliverable for this week's lab, so you don't have to submit a map. So some of you will be relieved for that. But anyway, there you go. That's this lab. You know, raster imagery is really cool, and UNT tends to focus a lot on raster imagery because this is especially in GIS because this is geography. So that's, we tend to focus on the impact of land, and that's what's represented in a raster. Anyway, this has been about a little over 20 minutes to show you about this lab. I'm going to go ahead and cut it off. As always, let us know if you have any questions. We will be around.